right, here's page 3, and we're getting into particle motion, just an example. And as with all these, know that just be flexible about the things that you're learning. These are examples that they won't be exact replicas of what you'd see on a test, but they're to get you going down the right avenue in various concepts, and particle motion is one of them. And if you remember, there's a question, average velocities happen twice. It happened on the first page, it's happening here on the third page. It's not a calculus question. Average rate of change is the slope of a secant line, and it requires only the function itself to get y2 minus y1 over x2 minus x1. And that's what I've got right here. So you're not doing any calculus. It's just putting 5 into the position function and 0 into the position, subtracting those. That's y2 minus y1 over the x's, 5 minus 0. You get 25ths. Of course, that's 4. And the units are change in y per 1 unit change in x. Still a rate of change, just like slope, instantaneous slope is. It's centimeters per second. But now that's part A, that's on average over that time, that's the rate of change. Is there a place on the curve where the instantaneous rate, which would be the tangent slope, speedometer reading type of thing, is the same as the average rate? So it's just kind of running you through an exercise of saying, what does instantaneous velocity, where does it come from? Of course, you got to take the first derivative, and then you need to equal it to set it equal to the average rate of change, which would be that secant slope we just got in part A. So we're setting the derivative equal to 4. So slope velocity is equal to 4, and we're going to find out what time, the t we get is the time when this occurs, is at 2.5 seconds. So at 2.5 seconds, the instantaneous velocity equals the average velocity over that period of time. There's something called the mean value theorem, which relates to this as well, and that's what it's getting at. But just in general right now, it's kind of an exercise of understanding instant velocity is first derivative, average rate of change is a secant slope. Describe the motion is to talk about right, left, and turning around. You're going to need the derivative, and you're going to need the critical values, because that's where the motion changes. So I got the critical value of 1/2. That's when the derivative, the velocity, is 0, which could mean coming to a stop and keep going, or it could be coming to a stop and turning around. So we need to look at the velocities on either side of 1/2 second to decide if it's going left or right, or going left and stopping and then going left again, or going right and stopping and going right again. All these are things that can happen. So I test by putting in 0 into the velocity, which is to the left of 1/2, and I get a negative. So that'd be left. And then I put 1 into velocity. So that's a 1 goes into velocity, I get a positive number out. And that means I'm going to the right. So I wrote those underneath there. From 0 to 1/2, it's moving left. From 1/2 to 5, it's moving right. That's the deal. The second piece of this is finding out where the graph below is differentiable and then doing a sketch of it. And I'll do that in the next video.